first thing you probably notice in this question is there's a lot of words. In questions with a lot of words, the best strategy is to read all the words first, read the whole thing through, so we've got an approximate model of the motion of the International Space Station is that it travels at a speed of 27,600 kilometers per hour in a circular orbit at an altitude of 400 kilometers. The radius of the Earth is approximately 6,400 kilometers. Visualize a line segment joining the space station to the center of the Earth to the nearest tenth of a radian, through which angle will the segment have rotated after 40 minutes. So we read it through once, take a deep breath, and then read it through again and try to draw a diagram of what's happening. So we've got our Earth. So I'm going to draw our Earth here. Oh, I'm going to add a lot of detail. There's Alaska, and Mexico, and South America. Oh yeah, there's some islands there, maybe Greenland, a little bit of Europe over here. Oh, Australia, Japan, a few islands. Perfect. It doesn't have to be that pretty, but you can have some fun with it. And we know that from the center of the Earth that our radius is 6,400 kilometers. A space station, we'll draw a pretty little space station up here. That looks like a space station. Looks like maybe some Star Wars ship instead, but that's okay. Is another 400 kilometers above the Earth. It's traveling in a circular orbit around the Earth. And at some point, it travels a certain distance after 40 minutes. So let's say it gets to that point after 40 minutes. We want to find the angle that it's rotated after 40 minutes. So drawing our picture, then looking at our picture, can help us also figure out what kind of stuff is involved here, what kind of question is this. And maybe at this point you can see this involves a radius, it involves an angle, and it involves an arc length. Because that portion that our space station has traveled, this purple part right here, is the distance it's traveled. That's an arc length. Well, how far has it traveled? It goes 27,600 kilometers in 1 hour, and it's traveled for 40 minutes. Will it be more than 27,600, less than 27,600, or equal to 27,600 in 40 minutes? What's that? Would it be equal? Well, if this speed here says that that's how far you would go in an hour, 27,600 kilometers in 1 hour, and you've gone 40 minutes, so you would have gone a little bit less than that. But how do we figure out what that is? We use the same ideas as proportions that we were using before. 40 minutes is a percentage of an hour. It's a proportion of the hour. How much of a proportion is it? 40 out of 60. That's your percentage that you've gone of the distance you would go in an hour. If we multiply this out, someone check that on their calculator. I think that's right. 18,400 kilometers. So that's this distance right there. We want our answer in radians, so we can use our formula for arc length with radians. That was that nice simplified one. S equals theta r. What do we know? What do we want to find? We know the radius of that arc length. We know the arc length, and we want to find the angle. So we can plug things in. The arc length is 18,400. The angle we want to find, and our radius 6,400 plus 400, 6,800. If we divide both sides by 6,800 to the nearest tenth of a radian, we get that our angle is 2.7 radians. Part B, I'm going to leave it right now. It uses something from grade 11, so if you want to look at it on your own, it uses the cosine law. It says, can you figure out this distance from there to there using your cosine law and using everything in radians instead of degrees? Questions for practice 8 and 9.